Where do we want to start? Is there any way I can minimize this thing on the left here so that it doesn't take up so much space?
No, I don't think so.
Okay. Let's see. One thing I can do is that. Where are we beginning here?
Problem 11, and so it's 11 through 15.
Okay. And you can read that? Because I can probably figure out how to blow it up. Yeah, I can. There we go. Okay.
That's fine.
So 11 through 15. Take a picture of it. Screenshot. So, first rule on factoring. What are you looking for?
Common denominators.
Greatest common factor. GCF is the very first thing you always look for. Always. No matter what you're looking at, if there's a GCF, you want to take it out.
Yeah.
Is there a GCF here?
No.
Actually, there is. W to the 8th. In other words, do not ignore the variables. Not just numbers that are GCFs. What's left over when I take a W to the 8th out?
So, 10W to the second, or squared, minus 19W, and then 6.
Plus 6. Okay?
Yeah.
So, that factors into those two things. And then that's a quadratic. So I'm thinking that that quadratic is probably going to factor also. So let's at least give it a shot. In other words, you always want to try to factor it. It may require the quadratic formula, but I bet it doesn't. How am I going to break up the W squared? What's the most likely way that it breaks up?
Square root.
5 and 2.
Oh.
5W and 2W. Now, it could be 10W and 1W, but the one thing we know is that these two things have to multiply together to give 10W squared. Remember what you're doing when you're factoring is you are doing the reverse of FOIL. FOIL is where you multiply it together. Factoring is where you unmultiply it. Well, when you unmultiply it, you still, the F of FOIL gives you that first term. Okay. Now, what are my signs? That's the second step of factoring. What do both signs have to be? I'm looking at just what's in the parentheses. Forget the W to the 8th for a moment. We've set it aside.
Positive and then negative?
No, you couldn't produce a plus 6 if they were opposite signs.
Oh, so they were both negative.
Exactly. They're both the same. You have to have the signs be the same to produce a plus sign. And if the middle term is negative, then they're both negative. If the middle term were positive, they would both be positive. Now we got factors of 6. Let's list all of the factors of 6 right there. Which two should we start with?
3 and 2.
Okay. Let's try 3 and 2, just arbitrarily. What does that produce for a middle term?
6W, or negative 6W.
Okay.
And then...
Remember, the middle term always comes from both of those added together.
Right, and then 2 times what is 10, negative 10, so that's not it.
Okay, so that's not the answer. Next most likely choice is the 2 there and the 3 over there. What does that give you as a middle term?
Negative 4w plus, or then 3 times what is 15, 16, 17. Yeah, that's it. So 19.
So that's our answer. And that's how you do these factoring, is you just try combinations. But the first combination you try should always be the factors that are closest together. That's why I chose 5 and 2, and that's also why I chose 2 and 3. Now, if 2 and 3 had not worked, then I would have tried 6 and 1. If 6 and 1 had not worked, then I would have tried 2 and 3 with 10 and 1. In other words, it is a trial and error process. You keep trying numbers until you produce that middle term. But just a tip is that it's almost always the two factors that are closest together. 3 and 2 are a lot closer together than 6 and 1 are.
Okay.
All right, that was 11. Are we doing odds or every one?
All of them.
Okay, let's do 12. Their greatest common factor. That's always the first thing you look for.
I guess v to the second. I think that's v to the second.
It's actually v to the 7th.
Okay, so v to the 7th.
What's left? What's going to be left is always going to be a quadratic. Because first of all, you can't factor linear terms, and they haven't taught you how to factor cubic terms. So the only thing that's ever going to be left here is a quadratic at this level. I say that, and I see number 13. So I take that back. That's okay.
Okay.
Quadratic is left on number 12 when you factor out a v to the 7th.
So 18 v squared plus 33 v plus 14.
Okay. Now, almost certainly that factors. Only because they're giving it to you. In other words, they wouldn't give this to you if it didn't factor. If you had to solve this using the quadratic formula, it wouldn't be in this section. Okay? So I'm pretty sure that there are probably two factors of that expression. What's the best way to break up the 18v squared?
Uh,
In other words, that's always the first step in factoring, is split that up.
so
Could be 18v, 1v, or it could be 9v times 2v. Or it could be 6v times 3v.
Nine times.
Always try the closest one.
Okay.
Not to say that that's necessarily the answer, but I've been doing this for a long time. 95% of the times, the answer comes from the closest factors. It's just the way they do it in Colorado. They make it easy for you. In other words, you don't have to try 15 different combinations. You start with one combination, the closest two factors together. Now, what are both signs? That's the second step.
Positive.
Now, what factors of 14 do we have? That's it. Which one should we try?
7 and 2.
No, 14.
What does that produce for a middle term?
What? 2 times 6 is 12. 33v.
Perfect. Notice that our first guess has been correct almost every time. In other words, using the two factors that are closest together is what I mean by our first guess. In other words, 6 and 3 worked, and 7 and 2 worked.
Right.
Because that produces 21v, that produces 12v, that gives you 33v, which is what we were looking at. That's the correct answer. So the final answer is v to the 7th times 6v plus 7 times 3v plus 2. So that's the answer they're looking for.
Okay.
All right, 13. You know what difference of squares is, right?
Difference of squares.
That factor. Upper right. A squared minus b squared. That's the difference of perfect squares. How's that factor? A minus b times a plus b. Always, 100% of the time. In other words, if I had x squared minus 4, that factors into x minus 2 times x plus 2. Because that's a perfect square, that's a perfect square. And they're being subtracted, so it's the difference of perfect squares.
Okay.
Okay? Now, clearly by the fact that you're being asked this question, they have taught you the difference of perfect cubes and the sum of perfect cubes. Let's first of all talk about the difference of perfect cubes. Because there is a pattern here. Okay? Notice that we have the difference of perfect squares, but we don't have the sum of perfect squares. That's because the sum of perfect squares doesn't factor. The sum of odd numbers does factor. So if this 3 is odd, then you can factor the sum of perfect cubes. And you can always factor the difference of perfect anything. You can factor the difference of perfect squares, the difference of perfect cubes, the difference of perfect fourths. Watch the pattern. In other words, that term is always linear and matches the sign of the problem in both there and there and there and there. And it's always a linear term. It's not squared or anything. Okay?
Okay.
The second term is a squared. That is always the opposite sign of this.
Okay.
And it's just a times b, and it's always plus b squared. Now let's look at a cubed plus b cubed. Always the same sign, and it's always linear as the first term. second term, just like above, that middle term is the opposite sign of the first term.
No.
Get it?
Yeah.
To memorize all three of those. And it's helpful in terms of memorizing it to memorize it exactly like this. I get some people that when I say, what's a squared minus b squared, they give me the answer a plus b times a minus b, which is technically correct, but it's not the way I memorize it. And the reason it isn't is because it doesn't fit the pattern. The pattern is the very first term needs to be the same sign as that sign. So I never remember a squared minus b squared as being this. I always remember it as a minus b times a plus b. That fits the pattern of the cubes also. And that's what's important, because you have to memorize all three. Okay?
Okay.
So in order to memorize all three, you need to establish some sort of a pattern. And that pattern is the very first term is a linear term whose sign matches the problem. In other words, that's minus, that's minus, that's minus. That's minus, that's minus, that's plus, that's plus. That's what I mean.
Okay.
And in the second term, the middle term always has the opposite sign of the first term, including that. That's a plus instead of a minus. That's a plus instead of a minus. That's a minus instead of a plus.
Okay.
Okay? Now, let's apply that to these problems. We were on 13.
Yeah. Give me a sec. I need to grab a charger.
Go ahead. Demetrius? Demetrius? Demetrius, are you still there? Are you still connected? Question mark. Hey, Demetrius. You must have got disconnected and I didn't realize it. Okay. The best thing to do is to sign out and sign back in. In other words, close out, go to meeting, and then just log back in, and I can use that meeting ID number again. You can use the same meeting ID number. I didn't close out my end. So the meeting ID number is 888-975 975-141. Hold on, make sure you get back into the meeting. I couldn't tell whether you were just away from the phone or away from the meeting. Oh, it's the charger you were looking for. I didn't hear those words. Okay, so we're back. Yeah, I'll hang the phone up here. All right, you can hear me okay?
Yeah.
All right. We're on number 13.
Okay.
Now, this lesson is on difference of perfect squares, difference of perfect cubes, and sum of perfect cubes. Those three things. What is number 13? Which of those three things is it?
It's the perfect cubes.
Is it
Or
the sum or the difference?
So the sum
or the difference of perfect cubes?
The sum.
Okay. So what we need, the general formula. It's always the way you start all math problems. How does the sum of perfect cubes factor?
It's A plus B, or yeah, A.
That's right. The sign is the same as what it is. Okay. And the next term is what?
A cubed.
No, it's got to be A squared. Because
okay,
you know that A times A squared gives you A cubed. Always. If that were A cubed, we would have A to the fourth. So it can't be A cubed. In other words, whatever that times that is A cubed. It has to be. Okay? Now what's the rest of it? The rest of it's harder to memorize.
So it's plus A.
Always the opposite sign of the first term.
Right. So
always.
Minus A times B, and then plus B squared.
Good. Now tell me what A cubed minus B cubed is.
A minus B, then A squared plus AB plus B squared.
Perfect. And then the last one is the one you first learned. What's A squared minus B squared?
A minus B, and then A plus B. Okay.
That's the simplest one. Difference of perfect squares is A minus B times A plus B. All right. So we've already decided this is the sum of perfect cubes. So how does that factor?
So
what is A plus B? First of all, tell me what A is.
1.
X.
Oh, X, right.
Right? In other words, I'm looking at A cubed. That's equal to X cubed. A must be X. What's
Okay.
B is going to be the cube root of that number. In other words,
Right.
what we're looking at is B cubed. So what is B? Cube root of 64. It's always going to be a small whole number. Four. 4 cubed is 64.
Right. Okay.
Okay? So, now, what is A plus B? And what is A squared minus AB plus B squared? What's A plus B?
A plus B is x plus 4.
And what's the rest of it?
X squared minus x, or 4x, plus 4 squared.
There you go. That's how you do it.
Okay.
In other words, once you know the general formulas, then it's all you have to do is figure out what A is and what B is. And A is going to be the square root, the cube root of that, and B is going to be the cube root of that. Whenever you're dealing with perfect cubes or sum or difference of cubes. Now, let's do 14. I'll put those three formulas up there, but at some point I'm going to erase them because I want you to memorize them. And you're not going to memorize them if I leave them up there. That's not the way you memorize stuff. The way you memorize stuff is to turn the piece of paper over and see if you know what it is. Okay? So, what is this? Is this difference of perfect squares, difference of perfect cubes, sum of perfect cubes? Number 14.
The sum of perfect cubes.
So we're going to use this formula. Tell me what A is, tell me what B is.
So A is Y, B is...
Do you have a calculator in front of you?
Yeah.
Take the cube root of 512.
11.3.
No, cube root, not the square root, the cube root.
Oh, my calculator doesn't have that.
Well, you need to do 512 raised to the 1/3 power. That's the cube root.
What? Oh.
512 raised to the 1/3 power.
Hold on. Oh. Eight.
Okay? So B is 8. Now factor that, knowing what A and B is.
Okay, so y plus 8, and then y squared minus 8y plus 64.
Huh? Okay. Now let's do 15. What is that? Which of those three formulas is that equal?
So it is the difference of the square or cubes.
Yeah, the way you can always tell is that. Okay? That's cube.
Yeah.
Therefore, it's the difference of perfect cubes. What's A?
Okay.
What's B?
A is G. And then B is
Once you've determined that it's the difference of perfect cubes, then you got to take the cube root of that number.
3, 4, 3, 7.
Now, what's the answer?
So G plus 7 times.
Hold on.
Oh,
The first term always matches the sign of the problem.
right. Sorry. It's minus 7. And then G squared plus 7G plus 7 times 7, 49.
That's it.
Okay, good.
Now, number 16, what is that? In other words, your first step is to figure out what you're looking at. Are you looking at difference of perfect squares, difference of perfect cubes, or sum of perfect cubes? Those are the only three you know.
Okay, so.
It's got to be one of those three.
Oh, that was it. We ended at 15.
Oh, really? Okay. What else do you have? Anything else?
Yeah, so 18. It skips to 18.
Okay.
So
Good.
it's the same. So it is.
Notice how easy 13 through 16 were. Because all we had to do was look at the first term to figure out what we were looking at.
Right.
This is a little different. Number 18. Is that the difference of perfect squares? Or is it the difference of perfect cubes? Or is it the sum of perfect cubes? Now, if it were cubes, 9 would have to be a perfect cube number. 9 isn't. So therefore, it figures to be difference of perfect squares. With me?
Okay. Yeah.
What's A?
A is.
And the way you get it is to take the square root of that term every time. Once you've decided that it's difference of perfect squares, the way to get A is to take the square root of that term and the square root of the other term. Hold on a second. Sorry, let's back up a step here. I forgot to take my own advice. They're a greatest common factor.
N to.
That's always what you want to do as a first step when you're factoring, is to see if there is a greatest common factor.
So N to the third.
It's actually 9n to the third.
Oh.
Now, how do I know that that number is divisible by 9? Is because all of the digits add up to 9. If you add 6, 5, 6, and 1, you get 18, and then 1 and 8 add to 9. That means it's divisible by 9. That's how you tell if a number is divisible by 9, is if the digits add up to 9. Okay?
Okay.
Now, So if I factor out a 9 into the third, what do I have left?
So n to the sixth or to the third, right? Yeah, n to the third.
Now divide that number by 9 on your calculator to see what's left.
729 and just 729.
N's go away. Yeah, just 729. In other words, if you multiply these two numbers back together again, you get what we started with.
Okay.
Okay. Now, this figures to be what? Which three? Difference of perfect squares, difference of perfect cubes, or sum of perfect cubes?
The
can only be one. We don't know if 729 is a perfect cube number, but n cubed is definitely cubed. So this can only be difference of perfect cubes.
Right.
What's
A? N.
What's B?
Huh. Nope, that's not right. 3.
Again, 729 raised to the 1/3 power.
So it's 9.
All right. Now put this in its final format. There's the front. What's n cubed? Or what's the formula? In other words, we're going to use this formula right here. So what's n minus b?
9. So n minus 9 times, n squared plus or minus.
No, it's always the opposite sign.
Oh, so I did have.
The sign of the first term is, the sign on the middle term, or the middle part of the second term is always opposite. Notice these three patterns up here. That's why I draw it like that, so you can see the pattern.
Okay. So yeah, it's plus. Then 9n plus 81.
Okay. And that's the final form, or that's the final answer. And just in case you're wondering, that can never be factored, ever, by definition. If you've started with the difference of perfect cubes or the sum of perfect cubes, this quadratic term over here never can be factored easily. And you can always factor it with the quadratic formula, but you can't factor it normally. So you don't need to even try, ever.
Okay.
Okay. All right. What's the next problem?
19.
Okay. Again, what's the first step?
Common factor.
Okay. What's the greatest common factor?
So definitely t squared.
T to the fourth. In other words, that's t to the seventh, that's t to the fourth. So definitely a t to the fourth can come out. What, is there a number that divides, there's at least two, right? In other words, we're looking at two even numbers. So 2 has to divide into both of those numbers, but is there a bigger number than 2? 4 divides into 16. Does 4 divide into 250? No, it does not. So 2 might be it. Let's try 2.
Okay.
That would leave what?
So that's 8t to the third. plus 125.
Okay. Now, you got to be able to recognize perfect cube numbers. In other words, this looks like it could be the sum of perfect cubes. The question is 8 a perfect cube number and is 125 a perfect cube number? Over here on the right, I'm going to write perfect cube numbers. With me?
Yes.
All you need.
Okay.
So, tell me what A is. Looking at just this part here. First of all, we're dealing obviously with the sum of perfect cubes.
Right. So A is 2.
2t.
T. Yeah.
In other words, 2t cubed is 8t cubed. So
Okay.
whenever you figure out A to be, when you cube it, it has to equal that term. And what is B? What's the cube root of 125?
5 cubed. So 5t.
Yeah, just 5. B is 5.
Okay.
Okay, so our final answer, there's our greatest common factor. And now we got to factor that sum of perfect cubes. What goes in here in the parentheses?
So 2t plus or minus.
It's always the same.
It is plus.
Yeah, because it's the same as that. Notice in our formulas here on the upper right, that's plus, that's plus. That's minus, that's minus. That's minus, that's minus. And all of those are linear terms. There's no squaring going on. It's just A plus B or A minus B. So it's always the same, the first linear term. Now what's the second linear term? We're dealing with this one here.
5.
What's A squared? Oh, I'm sorry. This is what you meant, was 5. Okay.
Yeah.
And now the next part of it?
It's 8t squared, right?
2t squared.
Oh, 2t squared.
Which is what?
4t squared.
Yes. In other words, when you said 2t squared, it was in parentheses like that. So
Right.
that comes out to be 4t squared. And then what else?
Plus.
Minus. Always sign is opposite the first one.
So minus 8 times b, so 5. 10t?
Uh-huh. And notice that all 3 last terms are plus.
Okay, so plus 25.
There's your answer. That's the final answer. And you never have to worry about whether that factors or not. It doesn't.
Okay.
This never factors. So you're done. Once you complete it to the level we've completed each of these problems, there's never any simplifying of it. Just so you know. I mean, you don't need to spend any time at all trying to simplify it.
Okay.
What's the next one?
Number 20. Yeah, 20.
Can I erase these formulas on the right?
Yes.
Sure, you got them memorized?
Yeah.
You know your perfect cube numbers?
Yeah.
Okay. Just remember that if the first term is cubed, then you can figure out that it's cubed stuff. Okay. I'm sorry. What was the next number? 19?
20.
20. Okay. This one right here. Now, because we're looking at a z to the 11th and a z to the 8th, you know you're going to be pulling out a what? In terms of greatest common factor. At least a z to the 8th, right?
Yeah.
Okay. Question is 1080 divisible by 135? If it is, you're going to pull out a 135 z to the 8th. And my guess is that it might be. I don't know. Is it?
What is it? 1080
Yeah.
divided by 135. It's 8. So yeah.
Okay. So what do we have left in here?
So z to the third minus 8. Yeah, just 8.
Okay. A factor. What is that called?
So that is the sum or difference of perfect squares
It squares.
or cube. I mean,
Okay. So it's this one right here. There's the difference of perfect cubes. Hold on a second. Let me get rid of some of my other writing here. That's confused it a little bit. All right. Now we're good. So what's A and B?
A is z,
B.
B is 8.
Nope. B is the cube root of 8.
Oh, right.
So what is B?
So
Once you've recognized it as difference or sum of perfect cubes, then the way to get A and B is just take the cube root of each. So what's the cube root
right,
of 8?
2.
Now, what's the answer?
So 2.
Nope. A is first. A
Oh,
minus
right.
B.
The z minus 2.
Okay.
Sorry. Z squared plus 2z plus 2 squared is 4.
Good. Perfect. Okay. Now, I hope we have at least one more of these.
I don't know. 25 is the next one.
Because I'm going to erase all of these. I want you to do it from memory now. Okay?
Okay.
You need to look at them for a last time. We only got time for one more problem.
Yeah.
So let's see if you can remember those three formulas.
Okay.
25. Naturally, it's not any of those. In other words, 25 is not difference, sum of perfect squares or perfect cubes. 25 is a completely different type problem. And I don't even want to get started on it because it's more than a 3-minute problem. But
Okay.
it's not difference of squares, it's not difference of cubes, it's not sum of cubes. It
Okay.
never is unless it fits the definition. In other words, that All of these, that's the sum of cubes. X cubed plus 64 is the sum of two perfect cubes. Well, 25 can't be, because 25 has a number in it. In other words, 25's got four numbers in it. There's no way that is the sum. Notice that the sum and difference of perfect squares and cubes are always two terms. That's two terms, that's two terms, that's two terms, that's two terms. Once you take out the greatest common factor, you're left with two terms. So sum and difference of squares and cubes are only just two terms. This is four terms. So that is not going to be what we've been working on. And
Okay.
like I said, that's a completely different problem. That's about a 10-minute problem to show you how to do. So we'll get started on it now. We'll end it there, and we'll pick up next Tuesday.
Okay.
Okay? All right, Demetrius. Talk to you next Tuesday.
Okay. You too.
Bye-bye.
Bye.